we learned that metal oxides are reduced to the corresponding metals by using suitable reducing agents like carbon. So here coke is used for reducing metal oxides to corresponding metal. The highly reactive metals such as sodium, aluminium are used as reducing agents because they can displace metals of low reactivity from their compounds. We have learned that the metals of high reactivity will displaces metals in low reactivity from its compounds. So these are highly reactive metals, so they are used as reducing agents. Let us take an example of manganese dioxide. This is manganese dioxide when it is heated with aluminium powder. What type of reaction takes place? As a result, we will get manganese Mn and aluminium oxide Al2O3, that is aluminium oxide, will be released. Also, heat is released. So this is an example of manganese dioxide. These displacement reactions are highly exothermic. The amount of heat which is evolved is so large that the metals are produced in the molten state, which means in liquid state. Let us take another example. If we take iron oxide, Fe2O3, and we'll take reaction of this iron oxide with aluminium, and then the reaction takes place. As a result, we'll get iron Fe in molten state, in liquid state. Also, aluminium oxide Al2O3 will be released with large amount of heat, and this heat which is produced is so large, and that is why we will get the metal in molten state, which means in liquid state. Now the reaction of iron oxide Fe2O3 with aluminium is used to join railway tracks. So this is how it is used. Also, it is used to join the cracked machine parts. Now here, if the railway tracks are destroyed, then it can be joined by this reaction of iron oxide with aluminium, and this reaction is known as thermit reaction. This process will be known as thermit process. Okay, which reaction is known as thermit reaction? The reaction between iron oxide and aluminium, that is known as thermit reaction, and the process which is used to join railway tracks, that is known as thermit process. Now let us learn extracting metals of high reactivity, or else you can say that extracting metals towards the top of the activity series. Now in the summary chart we can see the metals of high reactivity will undergo electrolysis process, and then pure metal will be obtained. We all know that the metals of high reactivity series are very reactive. We all know that, right? They cannot be obtained from their compounds by heating with carbon. They cannot be done with carbon. For example, carbon cannot reduce the oxide of sodium. Carbon can also not reduce the oxides of magnesium. Carbon cannot reduce oxides of aluminium also. Like this, the metals which are present in high reactivity series, which are highly reactive, which are the metals sodium, calcium, potassium, magnesium, aluminium. So carbon cannot reduce these metals oxides. Why is it so? Why carbon cannot reduce the oxides of these metals? It is because these metals have more affinity than carbon. What is affinity? Affinity is the tendency of the substance to combine with another. So here we can take affinity as the tendency of these metals to combine with another metal. So carbon has low affinity than these metals. That is why carbon cannot reduce oxides of these metals. For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chloride. The metals are deposited at the cathode, which is negatively charged electrode, and chlorine, which will be at the anode, which is positively charged electrode. This way, the metals are obtained. Similarly, aluminium is obtained by the electrolytic reduction of aluminium oxide. So there will be electrolysis process for this aluminium oxide, and from that aluminium is obtained. So basically, for obtaining the metals of high reactivity series, you need to remember that how are they obtained? They are obtained by electrolytic reduction. What is this electrolytic reduction? Electrolysis process of their molten chlorides. When we take example of aluminium, it is obtained by the electrolytic reduction of aluminium chloride. If we take example of sodium, then it is obtained by the electrolysis of molten chloride at the cathode, which is negatively charged electrode. So the metal will be deposited at the cathode, and the anode, which is positively charged electron. So chlorine will be deposited there, and by that the metal will be obtained. So this is all about occurrence of metals. Here we learned that the metals of high reactivity series are obtained by electrolytic reduction, that is electrolysis process. Then we have learned that the metals of medium reactivity are obtained as carbonate ores and sulfide ores, which are undergoing with calcination and roasting. Calcination is the process of reduction of carbonates into oxides by heating it strongly in presence of limited air, that is calcination. And roasting is the process when the sulfide ores will be converted into oxides by heating strongly in the presence of excess air. Then the oxides of metal will be obtained, and from that reduction of metal will be done. How the reduction will be done from oxides? By using reducing agent like carbon. Coke we are using for reducing it. So what will happen? That carbon will react with oxygen and it will form compound with oxygen, and that is why the metal will be reduced. Third point we learned, metals of low reactivity, they are found as sulfide ores. From that, roasting will be done. What is roasting? We have already learned, to reduce sulfide ores to oxide by heating strongly in the presence of excess air, and by that we'll get metal. At last we have to do purification or refining of metals, that we'll learn in our next sessions. Thank you.